So, at one point in history, we believed that there were five fundamental forces, that everything revolved around these five fundamental forces, whether it was the normal force, whether it's weight, whatever. It was an expression of one of these five forces. So I went ahead and I've listed the original five, and it turns out that this original five is no longer the original five. So they're electrostatic or electrodynamic would be the better one. Magnetic, nuclear weak, nuclear strong, and gravity. Okay, it turns out before quarks, before the understanding of matter, before the understanding of bosons, that we determined that the magnetic force that objects feel is equivalent to the electrostatic forces an object feel in a different reference frame. Excuse me. Okay? So the electron force, the electrostatic or electrodynamic force, is equivalent to the magnetic force. And we can thank Maxwell for determining that for us. So even before we have an understanding of messengers, that photons are communicating with each other, we already have eliminated one of the five forces. And as a matter of fact, we no longer call it electric and magnetic, we call it electromagnetic. So our five is now reduced down to four. So that electromagnetic force is the force that we feel either through magnetic fields or electric fields because of the same thing. They're just in different reference frames. Now, going back and talking about bosons, which we were talking about in elementary particles, the method of communication between electromagnetic objects, objects that feel electromagnetic forces, is the photon. Okay, and we generate these imaginary photons. Let me write that a little bigger. Is the photon. Okay, that's our messenger. Now they're virtual photons until they encounter another photon, and then they become real. But the method in which an electron can communicate with a magnetic field, or a magnetic field with an electron, or two electrons together, is what's called a photon. Okay, and that's one of our bosons. It turns out, after exhausting research and tons of dollars, is that the nuclear weak uses the same messenger. That those two forces, the electromagnetic and the nuclear weak, use an identical messenger. So because of that, we've combined the electromagnetic and the nuclear weak into one category. We no longer refer to it as nuclear weak and electromagnetic. We refer to it as, and I'm going to just erase it because I'm busy here, electromagnetic weak force. Okay? Which, again, is using a photon as a method of communication. Now, moving on to the nuclear strong, the particle, the virtual particle that's being created in order to have communications between nuclear strong. And when we're talking about nuclear strong, we're talking about the bonding between protons and neutrons. Bonding between protons and neutrons, and that is called a gluon. That's our messenger in which we communicate with one another. We use a gluon to do that communication. If we could figure out what a gluon really is, we may be able to reduce this into this other category. Instead of electromagnetic weak, I could call this electromagnetic nuclear. But as it stands, we only know of nuclear strong being communicated with one another using what's known as a gluon. Now, gravity is a mystery. We believe that the Higgs particle, what we're looking for, is a graviton. And that's the particle in which gravity communicates. Well, we don't know. So right now we just call it a graviton. Okay? It's a graviton. We don't know what exactly it is. Now, the interesting thing is that we've been spending a lot of money trying to study gravity and the graviton. One of the big things that we're interested in is whether gravity travels at the speed of light. If it travels at the speed of light, then we know that a graviton is a photon, and we're yet binding gravity to electromagnetic weak and maybe to electromagnetic strong. But as it stands right now, we're looking for a fundamental particle, a Higgs particle, which is a graviton. Okay? So those are my fundamental forces.